Chemical Equilibrium Part 8, Le Chatelier's Principle, and we're going to talk about concepts and the reaction quotient Q. Now let's talk about stressing a chemical system. So we're going to take a reaction that is at equilibrium and we're going to stress it. And so it's helpful to keep in mind that chemical reactions that are already at equilibrium, and actually any system, likes to stay at equilibrium. So if we do anything that disrupts this equilibrium state, it's considered a stress on that system. And while we think about these stresses, we're going to think about Le Chatelier's principle. And basically, this is a qualitative rule for predicting the direction a chemical reaction that is already at equilibrium will shift when we stress that system. So when we do something to it to disrupt that equilibrium, that's a stress. So what kinds of stresses are there? Basically, it's some change to the system, and so we can do that in various ways. We can add or remove product or reactant. So if we change the concentrations or partial pressures of any product or reactant, that's a stress. If we change the pressure on a system, that's a stress. If we change the volume of the system, that's a stress. So these two are going to apply to gaseous systems where one of the reactants or products, at least one of the reactants or products, is a gas. And then the other final stress is changing the temperature. So if we change the temperature, that's considered a stress. We're going to talk about each one of these, and in this presentation, we're going to talk about adding and removing product. In the next part of the Le Chatelier series, we're going to talk about these two on gaseous systems, and then finally we'll talk about temperature in a third part. So here's a formal statement of Le Chatelier's principle. So when a chemical reaction at equilibrium is stressed, so we do something to it, it will shift the equilibrium point in the direction that counteracts the stress applied. In other words, it's going to try to undo whatever we did to it. It's going to try to get rid of that stress. It's going to counteract, go in the opposite direction to what we did to it to stress the reaction. What happens if we add or remove reactants and products? If we add more reactant, for instance, let's go over here and look at our equilibrium constant expression, the simplified version where we just have products over reactants. If we add reactant, so let's add some here, then now Q is going to be less than the equilibrium constant. So Q is less than K. We have too many reactants. And so the reaction is going to shift toward products in order to use up or undo those added reactants. So it's going to move in the opposite direction to what we did. We added reactant, so it's going to move toward products to try to use up those excess reactants and get back to equilibrium. So here's an example. Suppose we add dinitrogen tetroxide to our reaction flask. And so here's our reaction, same one we've been talking about. Which direction is this system going to shift? Which direction will the equilibrium shift? So if we've added dinitrogen tetroxide, then we've added product right here. So that means that Q is going to be larger than the equilibrium constant value. So we're going to have too many products. We added products, so now we have too many products. It makes sense. So since we added product, then the reaction is going to shift toward reactants in order to try to get rid of some of that excess product. All right, next we are going to talk about pressure volume changes and Le Chatelier's principle.